My name is Zaan Swart. I've been a land surveyor registered since 1987, and I've been in private practice ever since then. Been doing townships, engineering work, all sorts of surveys, cadastral, topographical, precise, and photogrammetry.
Hello, my name is Swart. I'm a professional land surveyor registered in 2009. I'm a partner here at Zaan Swart Land Surveyors. I've been involved with basically cadastral, topographical, engineering, all the same disciplines, and recently in the UAV and aerial photography and photogrammetry.
When I started out, the land surveyors used theodolite and a tape in the early 80s. In the early 80s, the distance meter came out, and my dad was a land surveyor as well. He was one of the first to buy it, where you could measure a kilometer up to 5 millimeter accuracy, and that was a huge improvement on the tape, because your biggest enemy working with a steel tape is temperature. You never know what you can calculate, but it's difficult to measure the temperature and the tape's temperature to determine how much it expands in heat. Okay, now the distance meter made a huge difference, and then in the 90s the GPS came out, and that turned everything on its head, because now you don't have to see you don't have to see where you measure, you just walk there. And then lately we've been doing the photogrammetry with drones, and then making orthophoto from which you can measure with. So it's changed a lot.
They're calling them RPAS, the remotely piloted aircraft system or aerial system. Recently, it's become a lot cheaper to use them, because the conventional way of doing aerial surveys, or with that you need to have a dedicated aircraft with a fixed camera inside. It's very expensive, and nowadays with the UAVs and the drones, it's cheap to do smaller scale aerial projects with the smaller cameras and the drones. There's a few guys out doing it. When you talk to the guys at meetings and so on. The biggest thing is it's very expensive if you buy from the mass brands, the big brands. Their systems are very advanced, and it's very good systems, but they are very expensive. And the guys are, same with GPS, like Zaan mentioned. There was initially only a few guys that bought into the new technology, the expensive technology. And I think it's the same with this. There's a few guys that gone for the leap, and they did it, and you do pay school fees as well, with crashing and learning. But I think it'll get more and more. The guys are acquiring them, and it's become, depends on how you do it, but it can be, you can do it cost effectively. You don't have to buy the system from the big companies.
We use drones for photogrammetry, to make orthophotos that we measure from, and also do point clouds and digital terrain models. But there are many uses for drones. They use it for buildings, bridges, surveying of that, and even in agriculture, where they put a filter on it, NDVI filter, which they can see the crops, whether they've been overwatered, underwatered, they got illnesses, anything like that. Yeah, drones are used for volumetric surveys, topographical, and also for marketing.
Well, the conventional way of surveying, civil engineering based, is they're looking for a topographical plan of certain features which are not always as clear to the land surveyor. So it often happens that you miss information on site that you've got to go back for. If you've got a DTM model and the orthophoto and a 3D model, he can extract the data that he's looking for specifically from your UAV, aerial results that you send him. So it's, you don't get comebacks to go to the field again, and extra information and the visual aspect as well, because sometimes the engineer can't be on site or don't know what the site looks like. So with that, I mean, he's got a whole picture, a whole model of exactly what it looks like, and he can extract data. There's lots of software available where you can extract certain whatever he's looking for from that. So it's basically you've got all the data on that product. It depends. You've got precision estimates, so you can tell him that this is this accurate. We're qualified so that we can determine how accurate the data is, which he's getting. Which lots of guys that's doing models only don't really know if it's accurate or not, because we use pre-marks and coordinates, so it will be in a coordinate system. It's geo-referenced. Engineers will understand. They will appreciate the fact that it's scaled in meters or units that they're looking for, and the coordinates they can extract is in what they would use with their software. Yeah, we've done a survey on a trench that they did an excavation to go underneath a bridge, where we've surveyed it with GPS, conventional, and with the UAV, and I compared the results, and on any given point the height difference between the GPS points and the UAV was within 2 centimeters, 1.5 centimeters. So yeah, that was bare soil, so if it's just if there's trees or grass, then the height of the points becomes an issue. But if you can see the ground level, it's very accurate, extremely accurate.
What we do is we fly the site. We take the drone, program it, and let it fly the mission. Then we take the photographs and stitch them together with a program, with software. In one case, we used 200 photographs to make about a 25-hectare area to map it. We flew at 100 meters, which gives you 3 centimeter pixel size. So the points are within 3 centimeters correct, and double that in height. So it's 3 centimeters on the ground, 6 centimeters in height, which is sufficient for half-meter contours that we use. All software gives you the same result, or a result which is a point cloud and an orthophoto. You get different software packages, which like Pix4D, Agisoft, Photomodeler, but they're expensive, in the region of 6,000 euros. But you can rent them as well for a week or so. Just a practical example is this kudu head at the back, which my son photographed from different angles and built a 3D model and then printed it on a 3D printer. And it's this little copy of that head. Now, if you can model buildings in engineering, model buildings, bridges, rivers, to determine flood lines. There are just about anything that's got to do with engineering, drones can be used.
Yeah, it depends on the site. You get multi-rotors, it's quadcopters or all a variety of them, and then you get the fixed wing airplane, like a model airplane ones. If the site's small and in difficult urban areas, I prefer the multi-rotor, because landing and takeoff is not an issue, and you can fly between the buildings, and it's easy. But if the site gets to a larger area, then the fixed wing is definitely the way to go, because of battery life with the multi-rotor that doesn't last that long, and the wind's also quite a big factor.
Okay.
Well, you can probably squeeze 12 minutes out of the multi-rotor, but we never go more than 10 for safety reasons. And the fixed wing is about 30 minutes, I'd say. Yeah, but we never push it to the limits. So we fly for 30 minutes, and then we bring it down and change the battery.
The Challenges, the big survey companies sell ready-made packages where we buy a drone and the software. And those drones are, you take it, you shake it and throw it. It flies the mission. Comes back, downloads everything, or you download it and everything gets processed. But they are expensive, 600,000 plus. What we did, we built our own drone and used the camera, 12 megapixel, and you get open source software to program it with. So you've got an aeroplane with GPS, and you program it through the computer. You put the camera in. We also hack the camera to be able to take a photograph every 2 seconds. So we put the camera in, start the plane, throw it, and it flies the mission, and then it comes back and you land it. And you hope the camera is still intact. Here we have the airplane we use. It's just a basic polystyrene frame, but it's got a pitot tube which measures the airspeed, GPS and motion detection units inside. We put the battery in here, the aerial for the radio communication, and then the camera we stick in here. You can see the hole there, and put the wings on, connect the cables, close the hatch, and off you go. Initially we fly it with the radio, but we program the mission. So we launch the aeroplane, fly it with the radio, and then switch over to autopilot. It then flies to different GPS points, which we programmed. And the camera takes photographs every 2 seconds. And then when it's done, it comes back. Just a cheap 12 megapixel Canon.
We hacked the Canon with the CHDK, a Canon development kit that you hack the software to take photographs every 2 seconds, continuously until the memory card's full. Okay. It's the cheapest option. Otherwise, you need a trigger, you know. It's exactly the same as the same system, principle. Exactly the same. You just program it as that it's on another flying vehicle. It's not a fixed wing, it's a multi-rotor. Okay.
Now the batteries come in here, and the camera. But on this one we put a SLR, 18 megapixel gimbal. SLR. Comes on here, and this gimbal keeps the camera perpendicular to the ground, even if the drone turns. And then it also takes pictures, but 18 megapixel, which is better. Yes, okay. But not here. Yes, yeah. It's fixed in the body of the airplane. No, because we want photos to be perpendicular to the ground. It's only on the, we overshoot the area. So you overshoot and then it turns, and those photographs you don't use because it's oblique, and then it comes back on another path. And we use overlap of 80%, overlap, and 80% side lap as well.
This is the same as the airplane, the same control unit and GPS with the gimbal, and which controls the multi-rotor. It's the you know. This is the reason. This is a small one. You can basically take it with you every day if you want. It's not as I think they are getting smaller, so you can have one in your car for each job. So if you know, if you need to take it out and use it, it'll become a lot easier. Yeah. Initially, they'll get a nice looking, accurate base map model with a point cloud that they can use to do the planning and designs on, and then you can use drones throughout the construction process to, you know, to see progress, to do well, progress and calculate, you know, volumes, etc. And then at the end, if they need as-built, you know, results, you get an as-built, and all of the data is not a survey 2D plan. It's 3D models, color rich, you know, photographs that everyone can understand, and very accurate as well. So.
Okay.
Like I said, the survey companies do sell ready-made packages, but we build our own, or we have it built by experts. We don't. It's not our field of expertise to build drones. We do mapping. We do. We fly the quads, but the landing of aircraft, of the fixed wing aircraft in confined areas, we get a pilot. When we started out, there was no legislation, but we kept away from airports, and we kept low, like 100 meters, 125 meters. But now there's legislation where you can't, where they say you're not allowed within 12 kilometers of an airport, not higher than 100 meters. But there's a whole pilot license you must do these days to fly the drones. And also medical, just like a normal pilot's license.
And register your drone.
And yeah.
With a number plate or
registration number.
The registration number. And you need trained spotters as well.
Yeah, you must have spotters, which we do in any case, because you have to watch it all the time. I mean, we've had a drone flying, and then the battery went dead, and it just kept on gliding. And eventually we found it. Or the guy said to me, "How are we going to get it out?" So I said, "Where is it?" It was up in the tree. So luckily it got stuck in the tree, so we could get it out, and the camera was okay. Well, the package is 600,000 and more. The ones we built or have built with all the necessary equipment on is about 25,000 rand. And then the camera is a cheap 3,000 rand camera. We've done a lot of mapping for township development, where we fly a township, which is like a squatter camp, and then we make an orthophoto, and also we can do line mapping from it. Now, conventionally, you'll use an aeroplane with a mounted 1 million rand camera in it. Where, you know, I just told you what our costs are, and then we fly it in a day. We use no fuel, only battery power, and we do the processing ourselves, which gets you to the end product. In the old days, they had to fly it with a Cessna or some small plane with the expensive camera, and then also put it in a photographic machine, which took time, and it was like in my days when I studied in the 80s, it was 250,000 for that. It was called a stereo plotter, where you put two photographs in, and then you could see in 3D, and you could draw from that. That's in the old days. Now we do it with no fuel, and quicker and cheaper. There was one job we had to map a bridge, the Gautrain bridge, but the problem is we couldn't get in. I climbed over the fence, and the security guard saw me, so we made another plan. We flew it, And then we took pictures from the side as well, with the same camera. And then we stitched it all together, and we could make a 3D model of that bridge, of the Gautrain bridge, without touching it. We have flown over 100 hectares a day. We take up to 500 photographs, but that's not one flight. It's like 30-minute flights, a few of them, and then we stitch everything together. But we do it in batches. If you take too many photographs, it slows down the computer. So we take 200 maximum, and then you add them together in the end, because they're ortho photographs and they fit together.
Well, it can obviously be used because sometimes the areas are very difficult to get to, and you don't get a bigger picture in amongst the bush, and you don't really know what's going on. With the drones, you can get an overview shot of the whole area, and with the contours that can be generated from that, and to determine the flood lines, the 100-year and 50-year flood lines, etc. It can definitely be used, and afterwards, to assess the damages and stuff. It can also be used to see what happened, and I know insurance companies in the US also uses drones for insurance purposes on buildings and disaster areas afterwards.
Yes, drones can be used for health and safety inspections, and also in conservation these days. I know a guy who built a drone to fly his whole farm, and he watches it on his iPad live. But it can be used for everything. Well, they'll have to use it more. The computers can handle much bigger models, like point clouds, which are a couple of gig. But with the new computers, it will be used more. If you're not going to use it, you'll stay behind.
Yeah, if you want to know what's going to happen in Africa, you must look at Europe and America. That's my opinion. And it's a completely different continent, different stories, but it's very dense, built-up environments that they're dealing with there. I think the drones will. It actually collects too much data, in my opinion. So you basically dump the engineer with too much data, but with the extraction capabilities, he's got everything that he will need in the solution, the drone solution, with the models and the things that we can produce. So to extract from there, I think that's going to be useful, and also documentation, and like Zaan said, with the computers getting, the software is getting so advanced that it can handle all that data that you produce.
Yes, I think so, but the personal touch will still be necessary to be on site, but drones can definitely do part of that job.
It's difficult to answer that question. Usually the orthophotos and the photographs that we produced it used to be a nice to have, because you still produce the plan that you would, and sometimes you have to go survey it anyway. So there wasn't too much interest. The interests are getting more and more regarding the results from the UAV surveys we're doing. For the work we do, it's definitely a cost saver when it gets to mapping rural areas where they're doing a township establishment or planning to do townships. Because the old days we used to, well, not the old days, the other day, we used to do it with GPS, and to survey all the shack positions, it takes days, and it's definitely a cost saver to fly the orthophoto and then to map from there. And you've got a good backdrop of the site, and you've got the accurate line mapping that you would have surveyed anyway. So you save a lot of time there, definitely.
Yeah, I would say we can do it at a quarter of the cost of what it used to be.